Okay, here we go. So, we're talking about circle trig again. And today isn't nearly as dense and complicated as it was yesterday. If you remember some of those things, I don't expect you to be perfect, but if you can bring some of those things over from the last couple days. Like this one right here, I hope you know it's 30 degrees and it's also what? Pi over 6. So if I asked you to tell me what this one was, don't say it out loud, count it across in your mind. Is it pi over 6 with, except a lot farther, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, like that? What was it? Say it. 8 pi over 6? All right, now I can double check you here. 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6 makes sense, right? Because that's 1 pi. 7 pi over 6, 8 pi over 6. There we go. Could you reduce that? Sure, but 8 pi over 6 is great. All right, so now, let's say I wanted one of the others that was not the 30-60 kinds. Let's say it was, I wanted this one here. I know how many degrees it is. What I want to know is how many pi is it? In other words, how many radians is it? Do you get that this one's 1 pi over 4? Otherwise known as pi over 4. 2 pi over 4, 3 pi over 4. Raise your hand if you had the right number in your head. Okay, good. Then you're basically starting to master what the unit circle has to offer. All right. Now let's move into these. You've got to know these back and forth and upside down. 1, 2, square root of 3. But what if I'm not nice and I don't use 1 and 2? What if I use 17 right there? 17 over root 3. Good. And then what's this one? 2 times that, which is what's twice 17. 34 over root 3. Good. Okay. So this one's normally 1, 1, square root of 2, but what if I'm not nice? And what if I say that's 46 right there? 46 over root 2. Good. And so's the other one. Okay. Next. The unit circle. If it's truly the unit circle, how long is this? 1. And then, if I set this up as this is theta, this has to be x, and this has to be y, because that's the way x goes and that's the way y goes, then do you get that sine of theta should be opposite of our hypotenuse y over 1, which is y. So sine's y. What's cosine? Cosine's x. And tangent? Y over x. But since y is sine and x is cosine, do you get that that follows that tangent is sine over cosine? Do you get the ramifications of that? That means that you would never have to use the tangent button again if you didn't want to. What could you do instead? Find the sine of it and then divide by the cosine of it. We'll give you the tangent. Okay. That's going to come in handy in other places in the future here. All right, so now what if this isn't the unit circle? What if this is actually like 12? Well, and it's not really, sine really isn't just y, it would be y over 12. Because sine is opposite of hypotenuse, that over that. So it would be y over 12. This then would be x over 12, and is the tangent affected at all? No, because it doesn't have any hypotenuse in it, so it's still y over x. All right, next thing. Here it is. And what are the big red letters are talking about? All students take calc. What does that remind you of? They're all positive over there. What's positive over here? Sine, what's positive in this quadrant? And in this one? All right, so if I said I want to know the place where sine's positive and cosine's negative. Where is sine positive and cosine's negative? There's only one spot. Is it here? No, because they're both positive. Sine's positive and cosine's negative. That would have to be sine's positive and cosine. That'd be right here. That'd be that one. Okay? They're going to start giving you questions like that. They'll say, the secant of this is 5. And, by the way, cosine is negative. And you're going to go, okay, well, if cosine's negative, which of these could I be in? And you'll say, okay, cosine's negative, I can't be over here, and it can't be over here. If cosine's negative, I must be either in this one or this one. And then if they told you that, like, sine was positive, you'd know, oh, I must be in here. Or if they said tangent is positive, you must be in here, etc. Okay. So now let's see if you get some more of these patterns in the unit circle. Would you please draw your attention to this spot right here? Do you see those same exact numbers anywhere else? Straight across from it. Right over there. Same exact numbers. Why would that be? Well, because it's a 30, 60, 90 triangle. Both places. See, here's the 30, 60, 90 for this one, and here's the 30, 60, 90 for that one. It makes sense that they would both have 30, 60, 90s. Okay, and they'd have the same kind of numbers. Why is one of them negative? Because it goes to the left. Instead of just going to the right and up, which are both positive things, it goes to the left and up. And so now it's negative. Do you get that? Let's go together. Are there more that go together with those? The ones straight across from them. Like straight down here. And straight over here. Did I miss it? Sorry. B. All right. Right there. And up there. See how it makes a box? Are there other boxes that can be made? Yeah. These guys are the same as these guys, which are the same as, let me make sure I do this right, this and that. All right. Okay, so just wanted to look at a few more patterns in that. Now, this, I want to remind you that sine and cosine are the same basic thing, just shifted over. How far is it shifted? Well, it's shifted as far as if I get that top to be right there, so that's the distance it's shifted. How far is that? It's from here to here. How far is that? Pi over 2, or 1/2 pi. In degrees, what is that? Pi over 2, 90. So if you shift it 90 degrees, it'd be the same exact thing. All right. Next thing, do you get that this thing repeats over and over again? See how the answer to sine is 1 here, and it's 1 there, and it's 1 there? How far apart are they? Well, let's go from this one to this one and see if you can tell how far apart they are. It goes from that one to that one. Think of it as 1/2 pi going to 2.5 pi. How far apart are they? 2 pi. Does it make sense that if I rotate all the way around the circle 360 degrees, I'll get the same answer as I had before? Yeah. So they are, this is called its period. It's from there to there. Yes, unfortunate word, but that's what it is. And its period is 2 pi. It takes 2 pi to get back to where it was in the first place. All right, so this one, draw a triangle for each of these, label with sides like square root of 3 or 2 or -1, and be careful with the negatives. I got 3 lines there. One's black, one's red, one's green. I want you to draw this thing. Don't have to draw all the little hash marks, just the red, green, and black one. And then draw me a triangle that goes with each one. If you're drawing your triangles wrong, we want to catch that now. So try this. Label it with the sides like, oh, I can see that's a 45, 45, 90. It's 1, 1, square root of 2. This is not a unit circle. So you can use the sides that you like, the ones you already know, the 1, 1, square root of 2, or the 1, 2, square root of 3, that kind of stuff. So make sure you're careful with your negatives. I'm going to pause while you complete 3 triangles, one for each of these. No. Okay, so here's what you should have done. You go like this, you go like this. Did you realize that that was a 1, 1, square root of 2? Raise your hand if you had that one right. Okay. Nope, I said this was not in the unit circle. But if you were going to do it that way, you divide everything by square root of 2, and that's what you would have had. Okay, anyway, back to if you wanted this to be a triangle, you go like that, and it's a 30, 60, 90, and that's 1, 2, square root of 3. What if I had needed this to be the unit circle? Then I would have divided by 2 everywhere, because see, then that makes that a 1. Divide by 2, divide by 2. You get that? I didn't ask you to do that. I'm just saying if you wanted it to be that way. Oh, I forgot the negative. Where is the negative on this one? On the root 3, yes. That was a negative, sorry. Okay. And now, let's do the green one. I'm going to erase this to make room. The green one goes up here. And this one has a couple negatives in it. It's a 30-60, or is it a 45? No, it's a 30-60. So then this is 1, 2, square root of 3. But then there's negatives. Negative and negative. You get that? Raise your hand if you drew the right triangles. Okay, good. If you didn't, then you should be scared, because this is so much of this on the homework and so much of this on the tests that you've got to be able to get these triangles right. If you know what you did wrong, then that's probably all right. In the back.
I did by like the last triangle on the bottom.
Yep.
I did it except on the vertical straight line. Yeah,
How do you know which way to do it? Okay, you needed to have this be the central angle. So I drew this triangle the only way you could have drawn it correctly. Let me show you what I mean. If I had gone with, okay, why can't I go this way? Okay, well, then, do you get that, okay, that is a triangle, and it is a 30, 60, 90 triangle. But do you get that there's a totally different angle in here than the way I did it? So if you go like this all the way around to here, that is a 180 plus another 60, that's a 240 degree angle. What should go with that is not a 30. Do you get what I'm saying? All right. Because there's only one reference angle that goes with 240. So if I want to do like sine of 240, there's only one other angle that could replace that, and it's not 30. Okay, so you got to draw the triangle the other way. So I'll show you what that would look like this. And then this 240 degree angle here has been replaced with this guy, and that's not a 30, it's a 60. Okay, the angle has to be at the middle, and bottom line is, here's a really simple way to do it. Look which way I drop from the point. I'm going to go back to the way they were when I first started. There. Watch which way I drop from the point. And you always make a vertical line. Always make a vertical line to make your triangles. So if you had trouble drawing the triangles a different way, always start at the point and drop a vertical or raise a vertical. Okay? All right. So moving on. What are some things that you're going to have to be able to do on today's homework? Like, they'll just say cosine of 150. Just like the first day or two, we said things like, what's cosine of 30? Well, you draw a 30-degree triangle and you get the answer. This one, you got to know enough to make your triangles in this little shape. You always start with one of these, like a bullseye, and then you go in and put 150 in there. If you don't know where it is, just estimate. Well, I know it's a little less than 180, so I'm going to make it like about there. Okay? And then remember, you're not going to really use the 150. You're going to use this, which is what? 30. And now you go, okay, always from here, from the point, you drop a vertical line. And now I got a 30, 60, 90. And now I know that these sides are 1 and 2 and square root of 3. Unless they tell me it's the unit circle, in which case I'd have to divide everything by 2. Because then my radius would become 1. Get that? That's more complicated. We probably aren't even have that today. So back to this. Cosine of 150 is the same as cosine of 30. I can substitute the reference angle. So cosine now is adjacent over hypotenuse. And is that positive or negative? Negative. So it's negative root 3 over 2. That's the answer. Notice I did not ever use a calculator. I used my knowledge of 30, 60, 90 triangles to answer that one. All right. Here's another typical book problem, except you should try this one. Try tangent of 270. Sketch me a little picture. And I hope you'll realize you can't draw a triangle. But then you can do something else instead of drawing a triangle. You can know about the unit circle and where you would be and what point you would be at. To save the pain and misery, in case you haven't figured this out yet, 270 is down here. So if I'm supposed to drop a vertical, I can't, because I won't be making a triangle. So I drop another line right here on top of this one. So instead I go like this. That spot there, would you agree it's 0, -1? Would you agree that those numbers can give you the sine and the cosine and the tangent? I asked you to remember that sine was what? Y. Sine y. Okay? So if sine is y, if they'd asked me for the sine of 270, I would have said -1. If they'd asked me for the cosine of 270, I would have said 0. But what is a tangent? Y over the x. What's the y? -1. Over 0. And then kids sometimes forget and think that that's 0, and it's not. It's undefined. The answer is undefined. And if you typed it into your calculator, typed in sine 270, it would tell you undefined. All right, moving on. This is different. Why? Because last time I was giving you degrees. Now I'm not. Now I'm giving you sides. And I want to know the degrees. Draw me the picture and notice that this says negative. If you drew your triangle in here, you'd be not right because all of them are positive in there. Your triangle can't be here because all of them are positive. So, if it can't be in here and sine has to be negative so it can't be here, then do you get that my triangle has to be either here or here? Right? You can draw it either place and it will work. One last thing, if you think about it, that negative can't be on a hypotenuse because the hypotenuse is 0 is the radius and they're always positive. So if sine is opposite over hypotenuse, I would put the negative onto this. It might just help a little bit more. Okay. You don't really have to do that. It's just a tip. Okay, so if I draw this triangle down here, just pick one. I don't know, go with this. Then if this is the angle we're talking about, then the opposite side would be what? Sine is opposite over hypotenuse. Opposite side would be square root of 3. In fact, negative. Does that make sense that it would be negative right there? Yes, it does. And the hypotenuse would be 2. And then what would the other side be? 1. And therefore, -1, you're right. Thank you. -1. Therefore, what angle is it? That's a 60, but it's not a 60. Because if we said sine of 60, we'd be in this quadrant. It's not a 60. You have to back it up now, and if you know the reference angle is 60, what's the other big angle? To get here, it's not 60. To get here, it's all the way around there. See what I mean? So it's 180 plus the 60, 240. So my answer, theta must be 240. I think some of your minds just exploded in that last part. Okay, I think you got that this should be the 60-degree angle right there. But do you get why I can't say the answer is 60? Because sine of 60 would have been back here, and it's totally different. We weren't over there. We were all the way around here. 180 plus the 60. Final answer, the theta must have been 240. All right. And one more thing to blow your mind. Can you get that there is 2 answers then? Remember how I said we could put this in 2 different spots? I just did it over here. There's another answer. I'm going to go back to here. At that moment, I decided to do it down there. Now I'm going to decide to do it over here. And so if this is my triangle, And this is theta. And sine is opposite over hypotenuse, negative root 3 over hypotenuse 2. This would be a 1. Then this is 30. This is 60. This is 60 again. But what's a way to say that? Negative 60 would be a right answer. Sometimes they only want positive answers, though. A lot of times. So how do I get to here? By going this way. 300 is correct. So many kids are only going to give me one answer on the test on that one. And they'll be proud of themselves that they figured out that it has to be in this quadrant, but it actually could have been this quadrant or this quadrant. So there's two answers. One was this 60 here plus the 180. 180 plus the 60 being 240. Yep. So 240 and 300. You will get it wrong. Yes. I warned you, this class gets a little harder. It's not like that's impossible. Now that I've told you the secret, you just have to be careful. It's kind of like knowing that a lot of times we like to give you answers that have an extraneous solution. So you better go back and double check them all the time. Well, on this, when you're getting your degrees, remember, there's oftentimes a lot of different answers, a lot of different degrees that'll give you the right answer. If I go back to this picture for 1 second, do you get that there's a lot of different degrees that'll give you an answer of 1? This many degrees gives you an answer of 1, or this many, or this many. They all give you an answer of 1. There's a lot of different answers. So which ones do we want? We want the positive ones, not the negative ones, so we usually don't make you do that one. And we usually don't make you go past 360. So we just ask you, is there more than one answer in this zone? And in this case, for the one I was talking about, there isn't. But if I was talking about cosine being this or this, there's two ways you can get it, two answers. There's never more than two. Yes, sir? Back to the problem. Oh, that's not it. Where is it? Is that it? That's not it either. Where'd it go? There it is.
So for that one, if you got the 240, could you just add 60 and
Yes, you could. Would that always work, though? I don't know. That might. I don't want to promise you that, though. I know it'll always work if you get two triangles, but never heard of that before. And it could be a new method. If it turns out it always works, we'll call it the Silhowski method. Yes?
Should we say like the positive and negative?
Remember, the answers usually in the directions it would have said, give all the positive degrees less than 360, that will work. So you wouldn't have needed the negative one. Yes, you could get to this by going negative 60, but they want the positive way, so they'd want the positive 300. And these are both between 0 and 360, and they can't go negative. Yes?
how do you decide
Mr. S.
which number you put the negative on? Does it never go on the hypotenuse?
The negative can never go on the hypotenuse. That's the. Then you just have to use logic. Like if I knew it was tangent of theta is negative 2. Okay? Well, that would be negative 2 over 1, right? And now that negative could be on either one. But if I look where I am and I say, okay, if we're talking about, I know I'm over here, then the negative side, if I draw this little triangle, do you get only one of those sides can be negative? Only this side would be negative. Okay, so you have to use the logic of where you are. Like if I was here, then only this side right here could be the negative one. All right. Okay, and one last kind of problem. Find the cosine of the angle whose terminal side passes through negative 12, 5. Well, first on this kind of a problem, you start with one of these. Big surprise. We're pretty much always going to start with one of those. Everybody sketch me one of those. And now roughly sketch where negative 12, comma 5 would be. Just use any kind of unit you want. Doesn't really matter. Just get in the right quadrant. Negative 12, comma 5. It's like there, right? Okay, and I could have put it right on the circle if I wanted to. Do you get now that my angle is going to be based on these sides of this triangle? There's only one way you can make the triangle, right? You start with your point and you drop straight down from that, or straight up from that. And so now, if I know that it was negative 12, 5, this has to be negative 12, this has to be 5. You get that? So then can I find out the third side of that? Sure I can. I can use a squared, b squared, c squared. I'll save you some time. It comes out to 13. And now, find the cosine of the angle whose terminal side blah, 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 blah. Once you've drawn the triangle, it'll be easy. What's the cosine of this situation? Cosine is ka, so it's adjacent over hypotenuse. So can you see it would be this one over this one? So negative 12 over 13. What if they asked you for the sine of that? Well, it's just opposite over hypotenuse. It would be 5 over 13. Weird. Okay, this one, I thought there was only one cut. This is the last problem, I promise. Okay, so if sine of theta is negative 5/13 and cosine of theta is greater than 0, draw the triangle and find all the other functions. Here's the key here. What did they tell you by saying cosine was greater than 0? That cosine is positive. If cosine's positive, do you know what my options are? If cosine's positive, can't be here, can't be here. Get what I'm saying? Cosine, oh wait, I just did it wrong. It can only be there and there. Okay, forget that. It can only be here or here where cosine is positive. All right, and if sine's got to be negative, do you get that it has to be down here then? Because sine can't be negative up in here. All of them are positive in here. So I have to draw my triangle here. So I know it goes like this. And I don't know exactly what the angles are or anything, but I know it's a triangle in that zone. And now I know that the sine is, oh, wait a minute, opposite over hypotenuse. Opposite is negative 5. Hypotenuse is 13. We just did this triangle a second ago. It's the 5, 12, 13 triangle. If that's 5 and that's 13, this must be 12. That's because 5 squared is 25, 12 squared is 169, or no, 144. 144 plus the 25 makes a 169, and so anyway, 5, 12, 13 is a classic right triangle. So now I've got my triangle drawn. It should be easy. Find all the other functions of theta. All right, do sine, so let's do cosine of theta. And now if I ask you cosine of that, seriously, you did that 2 years ago. That's easy. Cosine, ka, adjacent over hypotenuse, 12 over 13, 12 thirteenths. I better check my negatives because people often make mistakes on that. Is that 12 positive? Yes, it is. Is that 13 positive? Yes, it is. So I'm good. All right. You'll learn more stuff. Your worksheet's right here. This is your homework for tonight. This here worksheet. 1, 2, 3, 4, 5. I strongly recommend you sketch a little triangle for each one. That's really what you're going to be doing a lot this semester. Drawing triangles.